Okay, moving on for question 15. It's our last question. It's logs. Captain's logs. Started last question. Here we go. So, log rules. I'll just quickly go over them. If we add our logs, I'll maybe just write it. I'll write log. My computer is dying a death. I'll write log here, and I'll write the argument, which is this term here, okay, inside the log. I'll just call that. There we go. Terrible handwriting. Apologies. Should on a GP. Right. So for logs, if we add the log, we multiply the arguments. If we take the logs away, we divide the arguments. And if we have a power on the log, so I'll say that's like x to the n. Again, pen. So we can rewrite that as kind of nx. We can pull the power down. So that's your, what you should think of. Very similar to your indices rules, isn't it? When you're multiplying, if you get x squared times x cubed, you're adding those powers, aren't you? When you get x cubed over x squared, you're taking those away. That would give you x. That would give you x to the 5. And again, if you get x squared to the power of 3, that would give you x to the 6. You multiply. So there's a real similarity there with those rules. If you remember these rules, basically that's the same for logs. Okay. So let's have a look. What can we do? Let's see an add. So I'm going to multiply my argument. So log 2, 6 times 12, so that's 72. Okay, and that take away 2 log 2, 3. Okay, so that's me done my first one. So I've put that together. And I'm going to do my power, I think now, I'll do the power. So 272 take away log 2, 3. Now that'll be 3 squared, so that'll be 9. So now I'm doing my power rule where that goes to the top. Very good. And now I've got a takeaway, so that is going to be a divide. So it's log 2, 72 over 9. So what's 72 divided by 9? That'll be 8. So don't forget your equal signs. So that's log 2. If it loads up. Computer's obviously on a long day. Very long day. There you go. 72 is 8. And what does that equal? Well, the other thing you could think to write here is log 10 of 100 is 2. There's two ways to think about this. It's a bit like a time machine. It's kind of saying 10, how many times do I have to times 10 by itself to get to 100? Like 10 to the power of what is 100? What's 2? Okay, that's one way. The other way to kind of visualize it is to imagine this little 10 just moves around over here. So the 100 stays where it is, and that's equal to 10 to the power of 2. That's, that's kind of the way I think on it. Right? So for us, I'd be saying, okay, 2 to the power of what is going to give me 8. And again, you could kind of write that by going, okay, 8 is equal to 2 to the power of what? I've just moved that little 2 around, around there. So 2 times 2 would be 4, times by 2 again would be 8. So that means the answer is going to be 3. So I'll just put my 2 there. So that's 2 to the power of 3. So I'll keep this in a little bracket just so you're kind of, you know what's going on. And that means my final answer would be 3. Okay. Done. So a really nice question, logs. I mean, look how easy that was to get those 4 marks. Think of some of the other questions we've done. So fewer marks available for much more work. Okay, and the marking scheme. I think you're basically getting a mark for each point. Yeah, you're getting a mark for every time you use a rule. So almost every line of work in here is a point. Okay, so great question to know, logs. Absolutely brilliant question to know. Same with the wave function as well, I think. So that's the paper done. I didn't do part A because I'm not doing those topics just now, but that was all the topics that my class has covered. So the circle, not terribly difficult, but it's very problem solving, so be careful. I think that's similar to the graphs again, not terribly difficult, but it can be wrapped up in confusing ways, so be careful with those topics. Get your factorising. I mentioned this in the comments. You only need to equal 0 if you're solving it. Otherwise, you don't need to equal 0. I've set that equal to 0 because I wanted to show you the the solving part, which it didn't ask for. Solving is where you find the roots. Factorising is the bit before. Okay, so sorry, watch out for that. I probably should have put that for that question. So watch out for that. But synthetic division of polynomials, a great one to have. We looked through further calculus, which again very prescriptive. You're given the formulas at the front. Your straight line question: m is tan theta. Learn your triangles. Get a sketch. Don't be scared of radians. Okay. Integration, get your limits and your dx, upper take away lower, and get that inside a bracket. Yeah, once you've got that and a substitution, you've got most of the marks. Don't worry about the last little bit. But yeah, there's plenty of marks available just for laying this out. Okay, so watch out for that. We did some functions. Just take your time. You're subbing one function into another, and then there was a complete the square that comes up a bit as well. So just take your common factor out, half the middle term, what are you taking away? And this is how your notes should start to be progressing. As you get on, you're trying to simplify the course as much as possible into its core elements. So a complete the square thing for me, maybe you write that down as an example, and you just kind of talk your way through it like a recipe. What are the little steps? So that's a great question to come up. When you see right angle triangles, you should be thinking, do your Pythagoras to work out the missing side, and then you're usually doing your double angle or your addition formulae expansions to solve that. And again, you're given them at the front, so you don't even have to remember them. You just have to know when you see cos, something plus something, or sine something, take away something, you're thinking it's going to be those addition formulae. But do your Pythagoras to work out the missing sides. And again, the first question was just a straightforward, sorry, not first question before, straightforward straight line question, PGE. Get that sorted out as well. We had the b squared minus 4ac, comes up a lot. I talked through the more difficult version of that question, which is a bit more common. So you're finding your roots, putting it equal to 0 for the roots, and then you're saying when is your parabola above or below 0. So I talked through that as well. We looked at chain rule. So for the chain rule, remember you're multiplying by the differential when you're differentiating. When you're integrating, you're dividing by the differential. And that's pretty much told to you in the front page when you look at your trigonometric function stuff, with the a side and all that. So if you forget this, it is there in the front page. And then we looked at inverse functions. You're just rearranging the equation and making sure you use the right terminology. So here your x becomes the inverse x and the y became x. Again, very easy marks for that, very easy. Don't forget when you put the functions into each other, you're back to where you started, so you're back to x. So that's a quick rundown of the paper, really fair paper, not terrible at all. For my money, your log questions, wave function questions, and further calculus questions are really good, rich marks. I think things like straight line and polynomials should be absolutely, we should have nailed them. And then really things like functions aren't even much of a topic. It's basically what we did last year. So that should be this. So maybe the only tricky ones then are your integration, some of the graph and circle work, which can be a wee bit trickier. Okay, but get those main topics in the bag, and I hope as you've gone through these questions from video to video and paper to paper, you'll see there really is a lot of similarity. So yeah, just try and learn that, the SQA way of thinking, and don't be, if you practice these, there's not many curveballs that can come up. Okay, so yeah, just keep practicing and figure out which topics you like. And yeah, I hope that's been helpful.